So I'll walk through what this system is and how it works. So this is our automated system for doing VO2 max testing. Similar to what we use for all of our other IWorx. We go to settings, so we want to pull up this program. We go to settings, and then it is under human exercise IWire, and then there's aerobic fitness. So when we click on that, we get our appropriate file that comes up. So this is the screen that we're going to be looking at. It can monitor 6 channels at one time. So in real time, it's going to tell us what the CO2 concentration is, what the O2 concentration is. It's going to give us the expired airflow rate. It's also going to give us the airflow cumulatively. So it's not going to give it by minute, but it's going to say at the 3-minute mark, the individual or the subject has breathed 70 liters. So it's going to be cumulative until the end. But when we do the calculations, it'll tell us what ventilation is in liters. It'll also display heart rate. So for this system, we have a polar heart rate monitor, and the normal chest strap will then send the signal to a receiver that's on the treadmill, and that information goes directly into the TA, and then that is displayed on the screen. So the nice thing about this system is in real time we can look at what our CO2 value is, what our oxygen value is, what our ventilation is, and then we can look at heart rate as well. Over here it'll also tell us what our relative VO2 is. So as we're going along, you'll see that the subject's VO2 after 5 minutes is 23 mils per kg, and as they go along you'll see that number get higher and higher, so we can see that in real time. It'll also tell us what our RER value is as well. So the nice thing about this is in real time you're looking at heart rate, you're looking at CO2, you're looking at O2 concentration. When I'm doing this test, to start with, I want to make sure that all of the values make sense. So as soon as we start the test, I want to make sure that that's a reasonable CO2 value, that's a reasonable oxygen value, that's a reasonable flow rate, and then I want to make sure that the heart rate monitor is working as well. The very first thing we want to do with this system is we want to calibrate it. So there is a calibrate gas analyzer. So as we've done before, we want to be able to calibrate this, and we want to make sure that the gas analyzer is calibrating correctly. So we go through the quick calibration procedure that we did before. We use room air, it calibrates to room air, then it calibrates to the calibration gas. So we want to make sure that this is reading correctly. So we calibrate for that. We also click on quick flow calibration. So we want to make sure that this flow meter is working correctly. So it's the same flow head that we used when we were doing pulmonary testing, but it's a larger flow head that's designed for VO2 max testing. You can put up to at least 300 liters per minute through that. So to calibrate that, the first thing we do is when we run the program, we allow no air to go through it for 10 seconds. And then what we can do is we can take a calibration syringe. So this is a 3-liter calibration syringe. So when I click on quick flow calibration, I hook this up to the other end of the tube, which is going into the mixing box, and then it'll say, don't run any air for 10 seconds. And then what I do is I start with this extended, and then I do 10 slow controlled pushes of the syringe, and so we know it's exactly 3 liters that is going in. So as part of this calibration protocol, we do a quick flow calibration. I do this 10 times. I then set my cursors in the right collection, right location, and then click OK, and then it knows that that was 3 liters of air that was coming in through each time. There's also a more elaborate calibration program that I did about a month ago. So there's a calibration program that you can go through where you do using the same syringe, but you're doing it for a longer period of time. So you're doing it up to 100 times and you're changing the rates. So one thing we want to make sure when we're using this is we want to make sure that it's calculating flow correctly. We want to make sure that it's calculating the oxygen concentration correctly and the CO2 concentration correctly. The only other thing we need to do with this is we need to put in some setup information. So we're going to click setup. We're going to put subject information in. So we're going to put subject name. The most important thing is to put the subject's weight. So if we're getting relative VO2 in real time, it's based on the subject's weight as well. So we can go into setup, and then we can put in the appropriate information, and then we're ready to start. And all we're going to do when we start this program is we're going to hook everything up. We're going to disconnect the tube so that no airflow is flowing through. We're going to click record. We're going to record for 10 seconds with no air flowing through. Then we're going to hook the other end of the tube into the mixing chamber, and then we're going to have the air flowing through from the subject of the flow head. And as I mentioned before, what we're going to do is we're just going to run the system for 5 minutes during the warm-up. So as the subject is on the treadmill, going at a low intensity, we want to make sure that everything is working. So I'm going to check my CO2 values, my O2 values, I'm going to check my flow, I'm going to make sure the heart rate is working. If I don't like something, I may actually stop the protocol and recalibrate, but I just want to make sure that everything is working correctly before we actually start the protocol, but because we don't want to have the subject do it twice. So relatively straightforward setup. If we look at our two modules that we're using, so this is our gas analyzer that's on the top, and we have a cable that's coming in from the heart rate sensor. The sample inline comes from the front of the mixing box, so the air is sampled from there, it's then going into it. And this is also a closed system. We don't want to lose any air. So instead of just having the air go at an outlet, the air goes back into the mixing chamber. So the key thing about this system is we don't want to lose any air. All of the air that the subject is breathing out, we want it going through the system, and we want it going through the flow meter. So this is our flow head, similar to what we've done before. There's two flow tubes that are on the top. That is going to hook into our TA. We've connected the gas analyzer to the TA. So everything is hooked up, ready to go, and again, we want to test it to make sure that everything is functioning correctly. We also have a mixing chamber at the other end of the flow head, and the reason we have a mixing chamber is as the air comes in, we want it to mix so that it's not stratified. We have a homogeneous air sample that's coming through. So typically when you see a system like that, you're going to have a mixing chamber where the air can come through, circulate around, and then we can monitor what the flow is. So that's how this system is going to work. Just a couple of other quick things that I want to go over. So this is the mask that we're going to be utilizing. The nice thing about this mask is it's easier to get a good comfortable fit, and you don't have to have a mouthpiece. As I mentioned before, the clear side goes out. So this is the side that we're going to connect to our tube that goes to our mixing chamber. So the subject is going to be breathing air out through here and going into the mixing chamber. The way this harness works is you can unclip one side, and then we'll clip it onto the subject's head by clipping it this way, clipping it in the other hole, and then if we need to adjust it, we can. I always have the subject do a positive pressure test where they put this on their mouth and hold these two ends and blow out, just to make sure there's no air leaking. So again, a big part of this is making sure that no air is leaking. So the subject's going to put the mask on before they get on the treadmill. We're going to make sure that everything is adjusted correctly. Then they're going to get on the treadmill, and we are going to hook the hose up from the clear side into the mixing chamber when we start the protocol. And the last thing that we're going to look at as part of our setup is this is our chest strap. So this is just a polar heart rate monitor. It works the same as our other monitors. So the one good thing about this though is the sensor is going to be at the front of the treadmill. It's going to pick up that information. It's going to send it through. It's going to send it into our IXTA, and then we're going to display that on the computer. So it's really important to be able to monitor the subject's heart rate as we're going through and working through the computer. And the last part of the treadmill, and somebody's going to be responsible for controlling the treadmill. So this is our treadmill. The nice thing about this old Quinton treadmill is that it will go up over 20 degrees, so we can do the Bruce protocol on this. It's easy to control the speed, and it's easy to control the elevation, and at the end we can quickly drop it down and get the subject doing a recovery at about 3 miles an hour at a very low grade. So the nice thing about this is it works extremely well, and we can get up into some higher angles or some higher grades, and we can get the subject up to their maximum heart rate.